Alright everybody, it's really important when you do these graphs of the sine, cosine, tangent, all these, that you get the 5 key points, or what I call quarter periods. The period is 2 pi divided by whatever's in front of this x. So 2 pi divided by 2 is pi. So that's our period. And if we take the period and divide it by 4, right, we're going to get pi over 4, and so that's how we're going to move through this. Alright, we're going to start with our midline would be at 0, so if I set this equal to 0, 2x equals 0 happens at 0, so that's going to be our starting point, and then the ending point would be this equal to 2 pi, the full period for the sine. So 2 pi divided by 2 would be pi, so that'll be our last value, and 0 would be our first value, and then we'll move up in units of pi over 4, right, the period divided by 4. So pi over 4, another pi over 4 would be 2 pi over 4, which is pi over 2, then 3 pi over 4, and then finally pi. And that's important for all of these problems, that you understand how to slice up the way that you're going to plot these points, these key points. Alright, so let's use that for one of these to see how this is going to work. Amplitude, that's the number in front of the sine or cosine. So in this case, it's absolute value of that. It's already positive, so we just take that number. Alright, the period is 2 pi divided by the number that's in front of x, so 2 pi divided by 3. So 2 pi over 3. And then we go to the phase shift. So that's going to be this number divided by that number. Now that's negative pi divided by 3. But you change the sign because it moves in the opposite direction of the sign. So meaning negative, we would move to the right. Positive, we would move to the left. So this is going to move pi over 3 units to the right of 0. Or the initial points on the graph. Like, for instance, what I mean by that is 0, 0 as a point on the sine graph. So this is going to move all those points to the right, pi over 3 units. Alright, and now we're going to graph it. So here's what I want you to understand. I'm going to make my graph, my grid match theirs. So they're going from negative 2 pi to pi, or sorry, 2 pi, positive 2 pi, and they have steps of pi over 2. Is what they're showing us that is. And then the y coordinates look like they're going from like negative 8 to 8. And they are giving us units of 2 on there. Okay, so there my grid matches their grid. Now I've got the graph there. It's muted because I don't want to see it yet. I want to plot the points that are going to be on this graph. So for sine, right, the sine function, everything is relative to the midline. And the midline is the vertical shift. So like a sine bx plus c plus d. D is the vertical shift. So the midline here is just, there is no vertical shift, so it's y equals 0. It's the x-axis is our midline. So we're going to start from there. We're going to shift it left and right. We're not going up or down. There's no constant being added to it. So we're going to come off of this midline, or have symmetry over the midline. How much we go up will be also how much we go down. Okay, now points that we're going to plot. I'm going to make a little table here. And these tables are going to be point coordinates. Now 0, 0 is typically a point on the sine graph. Right? 2 pi 0 is a point typically on the sine graph. One graph of the sine function. Pi 0 is typically on the sine function. And then at the midpoints, this pi over 2 and 3 pi over 2, we are at, let me start with the pi over 2. We are at the high points and the low points. So we're at 1, and then at 3 pi over 2, we are at negative 1. So this is the standard sine function. And again, there are 1, 2, 3, 4, 5 points there. These are the quarter points of one period of the sine function. Okay, now, first of all, the period of this function is 2 pi over 3. So this whole entire wave is going to take place in 2 pi over 3 units. Okay, that's going to be when we get back to the origin, or make one full revolution. Alright, so the number in between these, between 0 and 2 pi over 3, that is half of our period. So what I did, I just took 2 pi over 3 and I divided it by 2. And now that is halfway through there. Now, halfway between these points, these two are going to be shifted as well. Halfway between these points is when we would go up or down. So halfway between 0 and pi over 3, that's our first point right there, that pi over 3, halfway between those would be that high point. So halfway between 0 and pi over 3 would be pi over 6. And I'd hit that high point. And then halfway between these two, which is pi over 3 and 2 pi over 3, the halfway point between those, you can kind of see it, it's going to be that pi over 2. But you can also, it's just the average. The average of pi over 3 and 2 pi over 3 is 3 pi over 3, or pi. And then if you divide by 2, because it's the average, you end up with pi over 2. So it's just the average of these 2 points is the low point. The average of these 2 points is the high point. That's what's going to happen with those points. Now, the next thing we're going to change is the high and low point values. Our amplitude is 2. It's not 1. So this is going to go up. Instead of to 1 and negative 1, it's going to go to 2 and negative 2. Okay, so I adjusted the period. I adjusted the amplitude. Now I'm going to tackle the phase shift. All of these points, according to our problem, all of these points are going to be shifted pi over 3 units to the right. So this isn't going to be 0, it's going to be to the right, pi over 3 units. So this is going to be at pi over 3. Alright, if I add pi over 3 to 2 pi over 3, that's 3 pi over 3, or just pi. If I add pi over 3 here, I will get to 2 pi over 3. Alright, if I add pi over 3 to pi over 6, notice that's 2 pi over 6. Alright, 2 pi over 6 plus pi over 6 is 3 pi over 6, or pi over 2. Alright, and then the same thing here. This is pi over 2. If I add pi over 3 to that, that's 2 pi over 6, 3 pi over 6. That'll be 5 pi over 6. And once again, you see those same points. And that's where our sine function is going to go through. Those are the points that are going to be on our sine function. So when I go to graph, I'm going to just click that for the sine curve. All right, the amplitude is 2. Alright, the period is 2 pi over 3. There is no vertical shift. There is a horizontal shift of pi over 3. Alright, and if you see that it rotated to the right, I'm going to save that, and then I'll check my answer. But now that I've got those points on there, if I click this, it should go right through those points, and you can see that it does. And then you want to make sure that everything matches. So once again, we're going up and down between 2. We're crossing at 0. We're going down as we cross. It's going up at pi over 2. We hit a peak. Right, at pi we're crossing, and 3 pi over 2, if I wanted to look at that, I'm down at the bottom. So this looks good. This looks like that graph, and so I know that I feel comfortable and confident selecting the answer. But that's the thing with those. That's why this problem is so important. Sorry, not that problem. This problem is so important with understanding what to do with the rest of it. If you understand what happens at the quarter points are either going to be on the midline, a max, or a min. The quarter points of the period. For cosine, it's different than sine. For cosine, we don't start off like we did here. We don't start off at our midline and end up on our midline. We start off at our max and end up at our max. It's kind of like everything's shifted over. Our quarter points would be max, midline, minimum, midline, maximum for cosine. But for sine, it's midline, max, midline, min, midline. And that's what the 5 points, that's why it's so important to be able to understand how to use those 5 points.